Dear students, let's hope this video help. I'm going to introduce the law of sines. You did this last year, but we're going to remind it, okay? So why is useful the law of sines? The law of sines is useful to solve any kind of triangles, not only right triangles. So from now on, we have been using trigonometry to solve right triangles, but instead, the law of sines, it deals with all kinds of triangles. So here we have a triangle that it's not a right triangle, it's not a equilateral triangle, it's just any kind of triangle. And a triangle is formed out of 3 points that we're going to call A, B, and C. Okay, so when we use A and B, okay, to create a segment, we can call this segment AB or BC, right? That's how when we use or BA. That's we have been using this notation for geometry, right? Also, if I actually make another point here, let's call it C. Now we have this segment that would be AC or CA, right? Now, this angle here, the way we can name this angle, we learned in geometry that there's many ways to actually name this triangle. The easiest one for this would be call it A, angle A. The same name as the point. So we can call this angle A. So in here, in this example here, this A, B, C, they represent actually the values of the angles. So that would be angle B, this would be angle C, this would be angle A, correct? Now, even though this side here we would call it AB, right? Using the same notation we have just talked about. We're going to use another notation for the law of sines, so it helps you identifying which one is the opposite side of this angle C. Which one is the opposite side of this angle C? The one that's across, which would be this one. And we're going to call this one with lowercase c. This is uppercase c, this is lowercase c. For this one here, we're going to call this lowercase b because it's the opposite of angle B. And this one, well, Mickey's sick today, so Mickey's not here, but maybe look at this. We have a little baby today in class. So, so what would be the opposite side of angle A? It would be side A, right? Okay, so it's this one here. Okay, great. So, and then the law of sines says that the ratio between the sine of angle, let's start with A, with the angle, the sine of angle A over its opposite side, which would be A, equals the sine of B over its opposite sides, B, equal sine of C over its opposite sides, C. Okay? So here you have to, what you have to view here, and this might help, you have to, the drawing you have to build when you solve this law of sines problems, it's this. You have to view this. If you view this, then these problems are easy to solve. Okay? So knowing this, we're gonna try to solve first exercise. Now here they're asking us to find BC, the side BC. This is a segment, right? So this is the length of the segment BC, which is this one. So we're gonna call this side, because it's the opposite of A, we're gonna call it A, right? And now it would be nice if we actually do what we just have done. We pair the opposite, the angle with its opposite side. And then now we need to find one of these pairs again to be able to solve for A. Now the problem we have here is that this does not have its pair. We don't have the value for this. And here we do not have the angle, right? So the first thing we have to do is get another pair. And to get this pair, we actually can solve for B. How can we solve for B? Because we know that 82 degrees plus 55 degrees plus, let's call it angle B, equals 180, right? If we solve for B, we have 180 minus 82 minus 55. That way we can find the value of angle B, which is 180 minus 82 minus 55. That's 43. So this is angle 43, correct? So B is 43. And now I have this other pair, which is this one here. Correct? So now I have to build the equation. And now it's very important that we have this equation handy. And one important thing, before we keep going, we can either write this law of sines like this, or we can do the FUACA, flip them, and write it like this. A over sine of A equals B over sine of B equals C over sine of C. How this is possible? How can we just write it like this or like this? Well, because if you have 2 over 3 equals 2 over 3 equals 2 over 3, and we do the FUACA, we flip all of them, we will have 3 over 2 equal 3 over 2 equal 3 over 2, right? And this still makes sense and this still makes sense, okay? So we can use either. Now, when we're solving for a side, this is more convenient, okay? This is more convenient when I'm trying to solve for a side, while this is more convenient when I'm trying to solve for an angle. As we're trying to solve for a side now, this is more convenient, so I'm going to use this one. So I have, let's see, let me write it here then, which is A over sine of A equals B over sine of B equals C over sine of C. Now I'm using A and B. Those are the ones I will be using because C, I don't have all the information. So I'm going to be using A and B. So I'm going to be using this only. Okay? So I will be writing, well, how much is B? B is 43. Here we go. B is 43. So I'm going to just substitute B is 43. Then angle B is 43. Side B is 20, which is this one here. Then I have to find side A, that's my variable, and then A, which is angle A, which is 82. Okay, so now they have this equation, A over sine of 82 equals 20 over sine of 43. Now when I have this, how do I solve this equation? Well, this is cross multiplying. This will go up multiplying. And I have a equals 20 times sine of 82 over sine of 43. Okay, so I take the calculator and I do 20 sine 82 over sine 43. And I get 29. Okay, more or less 29. So that's it. This is 29. So that means that this side here is 29. Be careful when you compute with the calculator. Be careful. You have to be using degrees in here. If you're using radians, you would get a completely different answer. Okay. Okay, so that's it for Monday.